Have you ever heard the phrase, Houston, we've had a problem? It's one of the most famous understatements in history. It comes from the harrowing, real-life story of Apollo 13. This wasn't just another moon mission. It became one of humanity's greatest survival stories, a masterclass in ingenuity against impossible odds. Imagine being 200,000 miles from home, hurtling through the blackness of space, when your spaceship suddenly dies. Gosh, that's exactly what happened to astronauts Jim Lovell, Jack Swigert, and Fred Hayes. Their mission, intended to be the third lunar landing, turned into a desperate race against time to get back to Earth alive. Today, we're going to dive deep into the technical crisis that crippled their spacecraft and how a team of brilliant minds on the ground and 3 incredibly brave astronauts in the void pulled off a miracle. This is the story of Apollo 13's electrical failure, a testament to human resilience when everything goes wrong. The Apollo 13 mission launched on April 11, 1970. Everything seemed perfect. The massive Saturn V rocket performed flawlessly, and the crew settled in for their 3-day coasts to the moon. They were relaxed, even conducting a TV broadcast to show folks back home what life was like in zero gravity. But just under 56 hours into the flight, everything changed. Mission Control in Houston asked the crew to perform a routine procedure, a cryo-stir. This meant flipping a switch to stir the super-cold liquid oxygen and hydrogen in the spacecraft's tanks to get more accurate quantity readings. It was a task done on every Apollo mission, but this time, it was different. Jack Swigert flipped the switch, and a few seconds later, the crew heard and felt a loud bang. The entire spacecraft shuddered. At first, they thought maybe a meteoroid had hit the lunar module, which was docked right behind them. Red warning lights lit up the control panel. One of the main electrical systems, main bus B, was showing a massive voltage drop. This wasn't just a minor glitch. This was a catastrophe in the making. Jim Lovell looked out the window and saw something terrifying. He radioed back to Houston. "We are venting something out into space." That something was the very air they needed to breathe and the source of their power. The bang they heard was the explosion of oxygen tank number 2. Inside the service module, a section of the spacecraft filled with vital equipment. This tank had been damaged goods from the start, a ticking time bomb. A series of small errors and oversights on the ground, long before launch, had left it vulnerable. When Swigert activated the stirring fans, a short circuit in the wiring inside the tank ignited the insulation in the pure oxygen environment. The pressure skyrocketed, and the tank blew apart. But the disaster didn't stop there. The explosion was so violent that it ripped a panel off the side of the service module, and crucially, damaged the plumbing leading from the other oxygen tank. Oxygen tank number 1. Back in Houston, controllers stared at their screens in disbelief. The data was telling them an impossible story. 2 of their 3 fuel cells, which combined hydrogen and oxygen to generate all the electricity for the command module, were dying. The fuel cells were located in the service module and were fed by the oxygen tanks. With oxygen tank 2 gone and tank 1 bleeding out, their power source was rapidly disappearing. This was the heart of the crisis. Without electricity, the command module, named Odyssey, would become a frozen, dead tomb. It had the heat shield needed for re-entry, but it wouldn't have the navigation, the controls, or the life support to make it back to Earth. The mission to land on the moon was over. The new mission was simple and terrifyingly complex: survival. The decision was made quickly. The crew had to abandon the command module and use the lunar module, named Aquarius, as a lifeboat. This was a radical, untested idea. The lunar module was designed to support 2 astronauts on the moon for about 2 days. It now had to keep 3 men alive for nearly 4 days on a journey around the moon and back to Earth. But it had its own set of batteries and its own oxygen supply, completely independent of the crippled service module. So the astronauts shut down the Odyssey, powering it down to conserve its remaining battery power for the final moments of re-entry. Everything went dark. The hum of the machinery fell silent. They floated from the cold, dark command module into the cramped quarters of the lunar module. Aquarius was now their only hope. The journey home was a brutal test of endurance. Power was the most critical resource. To conserve the lunar module's limited battery life, Mission Control instructed the crew to shut down almost everything non-essential. The cabin heaters were turned off. The temperature inside the spacecraft plunged, dropping to just a few degrees above freezing. Water condensed on the walls and floated in icy droplets around them. The astronauts were cold, they were tired, and they were severely dehydrated, rationing water to make sure there was enough to cool the lander's electronics. They had to make Aquarius's batteries last for 90 hours, almost double their designed lifespan. Every amp mattered. The main guidance computer was off, meaning the astronauts were flying blind for long stretches. They had to perform complex course corrections by firing the lunar module's descent engine, a maneuver that had never been attempted in deep space before. It was like trying to steer a ship with a rudder you'd never used, in a storm, in the dark. But another deadly problem was brewing, one they hadn't anticipated. As the three men breathed inside the tiny lunar module, they exhaled carbon dioxide. On Earth, it's harmless, but in a sealed environment, it's a poison that can build up and suffocate you. The lunar module had filters, called lithium hydroxide canisters, to scrub the CO2 from the air. The problem was, Aquarius was only designed for 2 astronauts for 2 days. They were quickly using up its canisters. The command module, Odyssey, had plenty of spare canisters, but they were a different shape. The square canisters from Odyssey wouldn't fit into the round openings in Aquarius's system. It was a classic case of square peg, round hole. On the ground, engineers in Houston scrambled. They dumped a pile of items known to be on the spacecraft: duct tape, plastic bags, cardboard from flight manuals, and a second to a table and told their team, build a filter. They had to invent a solution, right there on the spot. Working against the clock, they devised a contraption and radioed the instructions. Step by step, to the freezing, exhausted crew 200,000 miles away. Using these makeshift materials, the astronauts successfully built what they called the mailbox. It worked. The CO2 levels dropped, and they could breathe safely again. It was a triumph of pure, unadulterated ingenuity. After looping around the moon, they were on the final, terrifying leg of their journey back to Earth. The last great hurdle was powering up the command module, Odyssey, for re-entry. It had been dormant and frozen for 4 days. Would its systems overheat? They had only the tiny bit of power left in its re-entry batteries. There was no room for error. The procedure for powering up the command module from a completely dead state had never been written. Engineers on the ground had to literally write the checklist as they went, figuring out how to transfer power from the lunar module's batteries to charge Odysseys, and then sequence the power up in a way that wouldn't overload the fragile system. One wrong step, and they'd lose their only ride home. The astronauts, shivering and weak, painstakingly followed the new, untested instructions. Miraculously, the systems flickered back to life. The hum of the electronics returned. Odyssey was alive. With the command module revived, it was time to say goodbye to their lifeboat. They jettisoned the service module first, and for the first time, they saw the full extent of the damage. An entire side panel of the spacecraft was missing, revealing a mangled mess of wires and equipment. It was a shocking sight that confirmed just how close they had come to disaster. Then, they jettisoned the lunar module, Aquarius, their cold, cramped savior. For the crew, it was an emotional moment. That little ship had kept them alive. Now, they were back in Odyssey, alone, hurtling towards Earth's atmosphere at 25,000 miles per hour. The final test was re-entry. The radio blackout as they hit the atmosphere was always a tense few minutes, but for Apollo 13, it was agonizing. The world held its breath. Would the heat shield, potentially damaged by the explosion and frozen by the cold, hold up? Would their parachutes deploy? The blackout lasted longer than normal. On the ground, the silence was deafening. And then, a crackle of static, and the voice of Jack Swigert. They had made it. On April 17, 1970, the Apollo 13 command module splashed down safely in the Pacific Ocean. The crew was home. The story of Apollo 13 is often called a successful failure. They never made it to the moon. But the mission demonstrated something arguably more important: the incredible capacity for human innovation, teamwork, and courage in the face of absolute crisis. The electrical failure that should have been a death sentence became a showcase for problem-solving under the most extreme pressure imaginable. From the engineers who jury-rigged an air filter with duct tape to the astronauts who endured unimaginable conditions. It's a story that reminds us that sometimes our greatest triumphs don't come from achieving our original goal, but from surviving the journey when everything falls apart. It's a powerful lesson in not giving up, even when you're 200,000 miles from home and all the lights go out. Thanks for watching. If you enjoyed this story of space survival, don't forget to hit that like button and subscribe for more tales from the history of exploration.